Hi, Marlena. Hi, Michael. Hi, Jacqueline. Hi, Clara. Welcome. Hey, Marina. Come on in. It's free prep hour. Hey, Monica. Hey, Jessica. Cool. Welcome. My name is Kat. Tonight is GRE free prep hour. I say that now because once we mixed up the LSAT and GRE rooms, this is GRE. Thank you all so much for being here. We're going to do some fun stuff tonight. We will be primarily communicating in the chat. I'm going to say hi in the chat now. You'll see there's a to field. Change that to all panelists and attendees so you can say hi to everyone. And then chat in and tell us, where are you in the world tonight? And maybe tell us something fun that you've been doing to stay sane during this strange time we live in. So say hi in the chat, tell us where you are. If you have any fun tips for quarantine activities, let us know. But I have left to be with my family with. Yeah, I've been doing a lot of workout videos too. Who knew that all it took was a global pandemic to get me to work out for the first time in years? Yay. Okay, good. I chose a topic tonight that I think will be, I find solving this type of problem kind of fun. So I thought we could do something that's sort of fun and puzzle-like, and maybe that would be a light thing. Dallas. Oh, nice. My mom's family's all in Texas. So I spent a lot of time there. LA. Cool. This is great. Well, thank you all for being here tonight. Has anyone been to a free prep hour before? Cool. And is anyone totally new to studying for the GRE? Like you're just getting started. So the way these work is we pick a different topic every time and we spend an hour on it. Most of the problems we're going to do tonight, oh nice Stephanie, are drawn from this book. Yay, 5-pound book of GRE problems. It is available as an ebook, so you don't have to get a paper copy. But if you need extra practice, it's great because it's enormous, it's tons of problems, and it's divided up by topic. So you can say, I want to do 40 probability and combinatorics problems, and there will be a chapter with 40 of those. And that is going to be our topic for tonight. We are going to talk about two topics that I think a lot of people don't like or find kind of scary. And I'm going to try to make them seem fun and not so scary. These are where he went last hopefully maybe seeing that they're a little fun. We're going to start with foundations of these topics, and we're going to work our way up to some. So it will be. To start, I wanted to actually just give a little update about the GRE though, because I know lots of things are in flux and there's a lot of news to track. And yes, administers the GRE. So give me like some, I can hear you in the chat, so I can check if it's my connection or not. Can anyone hear me? That's weird. I'm sorry about that. Huh. Hang on a sec. Let me see if I can fix it. Usually Zoom alerts me when there's a problem, and it hasn't alerted me, which is a little frustrating. Yeah, that's a good call, Angela. Let me make sure I'm on the right connection. Yep. Um, cool. Can you hear me now? Close out. All right. So back to GRE updates. Yeah, Zoom has been and the internet infrastructure in general has been very overloaded. I think so far I haven't had issues, but I think we have kind of a big group, and that might be why. So I was saying, if you haven't heard, in-person tests through April 16th are not running. However, ETS announced last night that starting today, you will have the option to register to take the test at home online. And those dates are going to start this Friday. It's available in the US and in a handful of other countries that are on this list. So you can go to the ETS website, you can look up the restrictions that you have to have not a Mac, you have to run a Windows computer. There's a bunch of other things you have to have sort of available in terms of your computer. But if you are looking to take the test in the near future, there is this new option that you could check out. So wherever you are in your planning process, just something to consider, to look into, to see if it might be a good fit for you. If anyone has questions about it, Kofi, that's a great question. I think at the moment they are allowing folks to reschedule. They're waiving the reschedule fee. I think you would have to either go on the ETS website or call them and see if you could change the test date you have to an online administration. So I would give them a call or email them sometime in the next day or two and see if that's possible. Yeah, it kind of has taken us all by surprise. So I don't know too much more about how they're going to sort of handle the scheduling stuff, but definitely something to look at. And the security measures for it seem to be pretty intense. So I think they are doing a lot to sort of make sure that these online at-home tests will be equivalent to going to a test center to take it. Okay. So let's get into our topic for tonight. You guys probably saw this slide, but you may not have heard me talk about it. We're going to talk about two less frequent. So these are topics that are not going to show up in 7 problems. They're maybe going to show up in 2 or 3 problems. Less frequent, but problems, topics that often give people a lot of worry and a lot of stress. And I want to try and eliminate some of that stress. So we're going to start with probability. We're going to start real simple, and we're going to build our way up into some pretty cool, complicated stuff. So my hope is wherever you're at with your math studying, you're going to find something interesting to take away. So let's start with something simple. I'm just thinking about the odds of a single thing happening, a single event. And I want to know, if I roll this die once, what are the odds that I'm going to roll a prime number? What do I need to think about when I calculate the odds of something, or the probability that something will happen? What's our core probability formula? Anyone? Cool. So when we think about probability, hi. Cool. Can other folks confirm that they can hear me? Yeah, thank God. All right. Yeah, cool. So we're thinking about probability. We are thinking, yeah, Stephanie said 3 out of 6. And that's what we are thinking about here. We're thinking about what are the number of things that I want, the sort of outcomes that are what I'm looking for, over the total things I'm choosing from, or the total possible outcomes. And that at its heart is all we need to do in probability, is think about what do I want? What are my total outcomes? So in this case, I'd say, okay, 2, 3, and 5, those are my prime numbers. So there are 3 things that I want. And then there's 6 sides on the die. What this means is that any probability is always going to be between 0 and 1. 0 means we have a 0% chance of something happening. 1 is 100% chance, total certainty. And you'll see probabilities used on the GRE both as fractions like this and as percents like this. Most common is fractions, but percents and decimals as well. What if I asked you this? I asked you, what are the odds of rolling a number that is not prime? What would the answer to that be? Yeah, there are 3 numbers that are not prime. Yep, 6 numbers total, which I could reduce to 1/2. Because I have not prime, not prime, not prime. Smith, do you have a question? If so, you're welcome to put it in the chat. Always, if you have a question, you can throw it in the chat at any point. Please don't be shy about asking. Something to notice here, the odds of prime, it is neither prime nor composite, but that still makes it not prime. If that makes sense, Prachi. Yeah. If it said, what are the odds of rolling a number that is composite, then totally right. It would be 2 out of 6. And that would be kind of a sneaky question. Just the kind of sneaky thing that GRE does. The odds of rolling prime or not prime, they add up to 1. Another way to think about probability, you can think about calculating what you want over the total outcomes, but you can also think about 1 minus what you don't want over the total. This is a second way to calculate a probability. We use it less frequently, but in some harder problems, finding what you don't want and subtracting it from 1 can save you a bit of time, can be a bit easier. All right. So far, so good. I hope I don't see any questions yet. Let's now look at something a little bit more complicated. Now I want to get into series of choices where instead of making one choice, we're picking multiple things. I'm going to roll this die twice. And now I'm looking to roll 2 prime numbers, prime on the first roll and a prime on the second roll. Whenever I see multiple choices in probability, I think about each choice individually, like this. So I'll start by thinking about what are the odds of getting prime on the first roll? What are the odds of getting prime on the second roll? And we saw, in any given roll, the odds are going to be 3 out of 6, which I'm reducing to 1/2 here to make my life easier. And now my question becomes, how do I then combine these probabilities? What operation do I use when I'm thinking about the odds of rolling a prime and then another prime? Cool, we had a vote for adding. Let's see what happens if I add here. I get 1. Does that make sense? Well, 1 would mean I was 100% certain that I'm definitely going to get 2 primes. And we know from, I think, life experience that that does not seem like 100% certain outcome. So you can always use common sense too in probability problems to double check your math. We will add at some point, JV. It's not going to be for this particular operation, but that is going to be an option for other situations. Angela said multiply. And if I multiply, I get 1/4. And to me, that makes more sense because I know in experience, getting the same thing twice in a row feels a lot less likely than that thing just happening once. And so it is making sense that I get a smaller fraction. So when you're thinking about this decision, how do you combine probabilities? One way to think of it is if it's a situation where you're looking for and or both, like I want this and then this to happen. I want both of these things to happen together, you multiply. If you find there's some situations where maybe thinking, is this an and situation feels tricky, you can also think about, should the outcome be less likely? Like, am I making it more difficult to get what I want by adding in these other options? And so that's another way to think about these cases where I multiply. And both a less likely outcome. Say something in the chat if you're like, okay, good, let's do something harder. Or ask a question. Give me some kind of affirmation. Because now I'm really paranoid people can't hear me. Cool. Yay. Awesome. All right. So here we're rolling the die twice again, but we're looking for something different. We're looking for exactly one prime. So that means one of our rolls has to be prime and the other roll has to be not prime. This is now a more complicated situation. Why? They've added like a whole layer of difficulty by changing this wording. Yeah, yep. So in this situation with 2 prime, there is only one way that I can get what I want. Yeah, I have like one pathway toward what I want. But as Angela pointed out, here I have a situation where there's more than one way to get what I want. I could have a prime on the first roll and a not prime on the second roll, or I could have a not prime on the first roll and a prime on the second roll. So now I'm in a situation where I could have this happen, or I could have this happen. And both of these are going to satisfy this condition that I'm looking to fulfill of having exactly one prime. Just like with the previous one, I do this kind of step by step. I start by calculating each of these pathways on its own. So I'd say like, okay, 1/2 odds of a prime, 1/2 odds of a not prime. I want this and that. So I multiply and I get 1/4, and I do the same thing down here because I want this and that, and I'm going to get the same probability, and I get 1/4. What do I now need to do with these two outcomes? Sort of option 1, I have a 1/4 chance, or option 2, I have a 1/4 chance. How do I combine these into my cumulative probability? Yeah, this is the instance where I add. Because I'm saying I could have this, or I could have this. Yep. I'm increasing the likelihood that I'll get what I want by giving myself more ways to get that thing. So in situations where we are looking for this or that, where we're making things more likely, that's where we add. So multiply for situations where I want this and that, and it's getting less likely. Add for situations where I could have this or I could have that. I'm giving myself more options. It's getting more likely. And you guys have now learned pretty much all of the core facts that you need to solve probability of increasing difficulty, up to, I think, some of the hardest problems in the official guide. the conceptual, there are kind of tricks and twists that we'll add on, but this is really all you need in terms of the foundational conceptual stuff for most probability. That's why I think probability is fun, because we're going to solve some tricky problems, but we're just going to use these same core tools to do it. So we're going to try a problem. We're going to start with something not too bad, and then we're going to work our way up to things that are increasingly cool and tricky. And the first problem that we're going to do is a quantitative comparison problem. So I think that we have a group that's mostly GRE veterans, but I wasn't totally sure. So I just wanted to quickly note how this format works. You're given some upfront information. You're given two quantities, A and B, and you have to pick one of four answers to describe the relationship between the quantities. Quantity A is greater, quantity B is greater, they're equal, or you can't tell from the information given. So these are our four answers. Go ahead and try this problem. And when you give me an answer to this, chat just to all panelists. So change that setting so you're just chatting to me, so you don't influence your classmates. All right, let's talk about it. Angela, I wrote your response to your question. That's a really great question, and I'm happy to chat more about it in a moment too. If the written response wasn't good, just let me know. So we have three flips of the coin. So I'm going to start by thinking about each flip individually. And I know I have a 1 in 2 chance of getting heads. One side that I want, two sides to choose from. How do I combine these probabilities? Should I add or multiply? Well, one way to think about this is just to try it. Like, okay, let's say we try adding. 1/2 plus 1/2 is 1, plus 1/2 is 3/2. Can I have a 3/2, like 150% probability, 3/2 probability of something happening? Yeah, that's, it's physically impossible to be more than 100% certain of something. So even if you're still feeling a little shaky on the should I add or should I multiply decision, which is definitely one of the trickiest things here, just try it out. And in a lot of cases, if you do the wrong thing, you'll just get an answer that doesn't make sense. And then you know to do the other thing. And that can be a good place to start from as you're practicing with this. So I've seen adding doesn't work. I'm going to multiply. And I'm multiplying because I want this and this and this. I want all three of these things to happen in sequence. And when I have three things that all have to happen, that's where I multiply and I get 1/8, which is less than 1/6. So B is my answer. Now, pretty much every time I teach this problem, and I teach it fairly often, somebody picks C. And it's usually someone who understands probability and has set this problem up correctly. Any thoughts on how folks get to C? My theory is it's just we forget. Yeah, I think we just forget our fraction mechanics when we're using them in a new context. And so if we knew this was like a fraction problem, we'd say, okay, multiply 1 times 1 times 1, 2 times 2 times 2 to get 8. But for some reason, when we have the new topic thrown in, it's really easy for the fundamental mechanics to kind of go to the wind. So I mention it because it's a common error, and also because it's just one of those little things you want to be attentive to. Even as you move into new topics, still being really precise, careful with the little simple mechanical things in them as well. If you're like me, small errors are a huge challenge in taking this test. That's definitely my big challenge in working with the GRE, especially quant. All right, here's a new problem. I don't want you guys to actually solve this. I just want you to read it and tell me in the chat what makes this situation here different from what you guys saw in the previous problem. Yeah, yep. Nice. Anytime we're picking things out of a jar, anytime we have a situation where we could potentially change the numbers, we have to think about, is the object we choose being replaced? And here, they don't say explicitly with or without replacement, but they do say that we eat it. And that's telling us, as Angela said in the chat, we're doing this without replacing it. So to pick 2 red jelly beans, what happens? Well, for my first pick, I'd say, okay, there are 5 red and 10 total. So there are 5 that I want and 10 total. And then, I'm going to pick another one. So I'm going to multiply. What is the second fraction? This is sort of pick number 1. What are the odds on pick number 2 after I've picked that first jelly bean? Yeah, nice. Good job, guys. 4 red left because I've eaten a red one, and 9 total left. So we have to think about changing both the numerator and denominator, or sometimes just a denominator if we're not picking the thing that we want. Yep. So always, always, always with multiple probabilities, we assume we get the thing that we want on our first pick. We only have to focus on the thing that we want. And so then once we've picked that, we've changed the numbers that remain. So in these without replacement problems, we're going to see a different probability for the second one. So that's sort of our final wrinkle in probability. I like to think of these probability questions as being kind of a series of choices. When I think about probability, I think, okay, first, I have to think about how many choices am I making? I think about the odds of each choice. Then I think, is it and or? And then I ask, is there a replacement or not? I also might think about, is there more than one pathway to get what I want? And if I am really rigorous about answering these 4 questions as I set up the problem, that'll get me through super tricky probability. It's still the same things I need to identify in each question. So I think it's time. I'm feeling good about this group. You guys are doing great. I think it's time to try something a little trickier. Here is a probability word problem. When you get an answer, chat it just to me, to all panelists. I'll give you a couple minutes to work on it. All right, just for the sake of time, I'm going to pause there. I'm going to try turning my video on. If you stop being able to hear me clearly, just let me know right away and I'll turn it off. So first sign of shakiness, chat me that you can't hear. All right, let's talk about this one. I feel more like human when I have a face. Pavel is going to reach into the bag and he's going to pick 2 chips. So right off the bat, I know we're going to have 2 choices. And then the other super important thing is that he is not going to replace them. First, he's going to pick black chip number 3, and then he's going to pick white chip number 3. And all of the chips are in the bag together, white and black mixed together. So I'm just going to start by thinking about what do I want and what is my total. Come back to that core idea. So for my first pick, what's the total number of chips that he's choosing from? And chat to all panelists and attendees so everyone can see. Yeah, I'm picking from the bag of 12. Nice. And then how many chips does he want out of those 12? Yeah, it has to be the specific black chip number 3. So there's only one thing that he wants. Cool. So he picks black chip number 3, he gets it, he doesn't put it back. Now how many total does he have? Yeah. Now he has 11. And again, he just wants this one specific white chip number 3. So he's just going to pick 1 for the second pick. And now I multiply them together and I get 1 over 132. And this is just what these fraction text entry look like on the GRE. I just input the numbers like that. And that's it. I know a few folks were like, oh, I'm still a little confused and working on this problem. Have I helped clear that up at all? Does anyone still have questions or points of confusion? For me, when I'm stuck, I really try to come back to this very core idea. And I even like visualize these in my head. I'm like, okay, how many chips are in the bag? What's the number of chips that I want on each pick? Just imagine myself in this situation doing this thing, and sort of making things concrete like that can be really helpful. I'm going to give us a sort of second version of this problem that's maybe a little bit trickier, has a little twist to it. So if feeling good, go ahead and jump into working on this. If you are still a little confused, please chat me. I'm happy to kind of talk through this one with you on the chat as folks are working. Here you go. And if you're going to chat me an answer, remember, just chat all panelists. All right. Let's try it. So we're going to pick 2 chips. So we're going to think about 2 choices here. And I want to pick a red. And then that red chip is going to have a number on it. And so then I'm going to pick that red, and I'm going to then get a blue chip with the same number. And I am not replacing. So let's do this one little piece at a time. Let's just start with 1 red. If I asked you, what are the odds of picking 1 red chip out of this bag of 12 chips? If that was our question. what would it be? Odds of picking one of our red chips out of our bag of 12. Cool. I'm seeing some different things. How many red chips do I have? I have 6. So I have 6 options to get what I want. Yeah. For that first pick, it just matters that I pick a red chip, any red chip. Then I'll deal with the blue chip later. But for the first pick, all I have to do is get red. So I have 6 out of 12. All right. Because any of those 6 numbers is fine for my first pick. And so I'm going to multiply. Now let's think about the second pick. Once I've taken out that first chip, what's my total for the second pick? Yeah, now I'm down to 11. And this, I think, is the trickiest part of the problem. How many chips do I have to choose from that are what I want? What's the numerator for the second fraction? Yeah, see, this is the tricky part. So let's just imagine what we're doing here. Like I'm gonna pick a red, and let's say I pick red chip number 3 on my first pick. What are my options for my second pick in order to fulfill this condition? Like what chip or chips can I pick? My second pick, if on my first pick I pick red chip number 3. Can I pick any blue, like could I pick blue chip number 2 or blue chip number 5? Yeah. Yep. Yeah, Claire, that's a cool way to think of it too. You could think of this as 2 separate, you could think of it that way, yeah. For sure. I think of it actually just as one choice. Like whatever I have to pick for the first one, like I'll pick a specific number, and then that will limit me to only one blue choice for the second choice. So it's like saying whatever number 1 through 6 I pick for red, then I have to pick that same number for blue, which means there's only going to be one blue chip that works after I've made my first. And Clara, you're multiplying those 2 together is going to get you to exactly the same place. And it's also a good way of thinking about it. I can reduce this to 1/2. And I can reduce this then as 1 out of 22. This is tricky. This is a tricky thing. My tip for all probability is to start by thinking about each choice one at a time. It's really hard, I think, to think about more than one thing together or once in general, but especially for probability. So if you can really think about each action separately from each other, it's going to help. What would help you? I'm curious. In the chat to everyone, what's something that you would want to sort of go back in time and tell yourself before starting this problem? What's something that's helpful to you? Yeah, I can totally pull those up again. Yep. So this is where I definitely think about each choice separately on this step. Yeah, I think with any word problem, read carefully. I like to read it twice because I find I do not process all those details fully on the first read. Take your time understanding the information. Don't rush into calculations. Each choice on its own. What else would help you? Or what's still not clear in this problem? Vanita, I can pull those up again later too if you want. Just let me know. I'll circle back to that screen. All right. JV, I like that problem you put up. I think we're actually going to do one that's kind of similar that might help you see how to do that one. And then we can chat about it, maybe if we have time as well. All right, we're going to do one last probability question, and then hopefully we'll have a little bit of time for combinations. We'll see. I was probably overambitious in planning, as I always am. Here you go. My hints for this are, remember the at least one prime situation. Like, start by thinking about the combinations of heads and tails that will get you what you want. That's my hint. If you get an answer, chat it to me. I'll give you a couple minutes to work on it. All right. Cool. I'm seeing good stuff. Okay. So let's start with my hint. What are the ways to get what I want? Two tails and one head. What are my pathways here? Yeah, nice. I have 3 ways. It could start with tails, then get heads, then get heads. Nice. Yeah, heads, heads, tails, and heads, tails, heads. Cool. So I'd say like, okay, 1/2 for each of these picks on the flip. And then I multiply them together because I want this and this and this. 1/8. Same thing here. Same thing here. These are all going to be the same. And now what do I do with these 3 probabilities? Yeah, I want this or this or this. So I add them up and I get 3/8. So same thing as that at least one prime. As soon as I see, okay, I could have these different orders, I could have these different combinations, I start by charting out those. I think about them each one at a time. Then once I have those total, I add them up. And you saw lots of folks getting to C, which was great because this one is tricky. Cool. Let's pause with probability. Just to recap, looking for things that we want over total outcomes, or 1 minus what we don't want. If we want this and that to happen, we multiply. But if we want this or this to happen, we add. And then also paying attention to situations where what we're doing might change our total. If we're picking things out of a group, do we replace or do we not replace? Lingering questions. Cool. We're not going to have time to cover combinatorics in full, but I do want to just look a little bit at it, maybe give you guys some tools for thinking about it, because probability and combinatorics are very similar, and we can actually use tools from combinatorics to deal with probability questions. JV, that problem that you put up in the questions is actually something that I would probably think about using combinatorics stuff. So maybe we'll get to a point where we can look at that. So switching gears a little bit, with probability, we're thinking about what are the odds I'm going to get what I want. With combinations, our task is a little different. We're just thinking about what are all of the options that I have. And it's kind of like the denominator in a probability, actually. It's like dealing with just that total. So let's start with something really simple. I have 5 pairs of pants, 4 shirts, and 2 hats. And I want to know, what are all of the different outfits that I could make? One way to think about this, and a kind of visual representation of the logic for a problem like this, is to imagine a decision tree. Like I start off with 5 pairs of pants. And then each of those 5 pairs of pants could be paired with another 4 shirts. And then each of those pairs of shirts could in turn be paired with another 2 hats, etc. So I could, in theory, draw this enormously complicated fractal tree and count up the number of branches. Don't do that on the test. This is just to illustrate the logic in our method. A much easier way to do it, draw a space for each decision. Label each of those spaces. I promise the labeling is going to become very important in a couple of minutes. And then write in the number of options for each of those labels. 5 pants, 4 shirts, 2 hats, and multiply them together. That multiplication is equivalent to this branching tree. It's a shorthand for it. And I would get 40 combinations of outfits. Exactly what we're doing actually when we multiply together the denominators of a probability. So go ahead and try this one. Same logic. or use the same method. Draw slots for each decision, label, fill each slot with the number of options, and multiply. Chat me when you have an answer. Cool. I'm seeing some good stuff. Apologies if I'm rushing you, but I want to squeeze in a little bit more stuff. I'm probably going to run about 5 minutes over the hour. If you need to sign out right at 9, I won't be offended. But we got a little slow start, so I thought I'd go a little longer. So I have 3 decisions to make. The number of spots that I draw corresponds to the ultimate number of people that are going to be in my group. So I have 3 spots. There's assigning books, there's summarizing books, and there's hosting. It matters which spot you are picked for. That's going to be really important in about 60 seconds. And then I think about how many people can I fill each spot with. So I'm picking out of 9 friends. So when I go to pick someone to assign books, I have 9 options. How many options do I then have for summarizing books? Yeah, Pachi said 8. Totally right. Once I've picked someone to assign books, I can't reuse them. So with people, it's like a not replacement situation. I have fewer options. I have 7 options for hosting. I multiply these together. If you can do that quickly on paper in your head, awesome. If not, you have a calculator, you can use that. And I get 504 options. There's a lot of different book clubs to make out of these 3 people. It's sort of a surprising amount. So this is also maybe a place where my sort of common sense reasoning is not super reliable. I rely on this method. How many people are in my group? There's a spot for each of the ultimate people in the group. Label each, number of people in each, multiply. There are other ways to think about combinatorics for sure. If you have a different method that you really like, do it. I've come to prefer this one over years spent teaching this because it is just a little bit simpler, requires less memorization, gives us some simpler math. So that's this situation, but there is one more big twist in combinations. What if instead of saying, okay, I'm going to have 3 spots where we're assigning, summarizing, and hosting books, I just have 3 spots that are all being in the group. I'm just going to say G for group. So all of my 3 spots are now interchangeable. Which situation is going to give me more options? Assigning people to specific roles or not assigning people to specific roles? What do you guys think? Yeah, I'm getting both answers. If you were saying that this one, specific roles, is going to give me more options, you are right. And I'm going to show you why. Let's say that we're picking 3 people and they're X, Y, and Z. in the specific roles version, I could pick X, Y, and Z, or I could pick Y, Z, and X, or I could pick Y, X, and Z. Each of these three groups is a different group because it matters if someone is assigning books versus hosting books. I can have the same three people, but if I arrange them in different orders, I have different groups. However, when I come over here to this case, these are now all the same. So a lot of the things that I was counting as different groups in our last situation, where we ended up with 504, are no longer going to be relevant in this situation. There's going to be some doubling up that I'm going to have to account for. And so in this new situation, I need to add in a little bit of a twist. I'm going to start exactly the same way. I'm going to draw out my slots. I'm going to do 9 times 8 times 7, same as last time. But now I'm going to take this and I'm going to need to divide it by something in order to get rid of this overlap. And what I'm going to divide it by is the number of interchangeable spots, which in this case is 3, factorial. This exclamation point, factorial, just means take a number and multiply it by each integer below it, like this. So in this new situation, I'm going to do this over 3 times 2. Before I get into that nasty multiplication, I'm going to reduce. And I'm left with 3 times 4, which is 12, times 7, which is 84. So now, in this new situation, I have a lot less options. This is why the labeling is super important. If I can label each spot as unique, meaning that it matters which spot I'm picked in, I'm good. I don't have to worry about this dividing by factorial thing. But if I have spots that have the same label where it doesn't matter if I'm picked in this spot or that one, this is where I need to divide. So just to recap our sort of method in decision making for this. Think about how many people are ultimately in my group. I'm going to make a slot for each of those people or things. I'm going to label those slots. And if all of my labels are different, I fill in the number for each multiply, done. If all of the labels overlap, or if some of the labels overlap, then I need to think about what are the number of labels that are identical, divide by that factorial, always try to cancel out first to make the multiplication simpler, and then you're done. So we're going to do one more problem so you can try out this method on your own. Please chat me. Yeah, assigning people to specific roles does give you more options. I just saw a chat. So chat me if you need a hint, but go ahead and try this one. All right. Not to rush folks, but I don't want to keep you guys too late. Let's do it. How many spots should I draw? How many slots should I draw? Come back to the all panelists and everyone for our last discussion. How many choices do I ultimately make? Nice. Yeah. I want to ultimately have a team of 5. So I'm going to draw my 5 slots. Are these labels different? Yeah, they're all the same. You're just on the team. If I was maybe going to pick some specific roles, like I'm going to pick a point guard and I'm going to pick a center, then maybe I'd have distinct labels, but I don't. They're just on the team. These are all going to be multiplied. I'm picking out of 9 people. So I'll have 9 people for the first, 8 for the second, 7 for this one, 6 for this, 5 for this. Because all the spots are the same, what do I need to then divide by? Yeah. For a moment, instead of reading 5 factorial, I read that as like 5. I'm excited about 5. But no, it's 5 factorial. 5 times 4 times 3 times 2 times 1. And now I'm just going to do my canceling to make my life easier. Get rid of that. 3 and 2 cancels out 6. 8 and 4. So I have 9 times 2, which is 18 times 7. That's going to be 70 plus 56, 126. And my answer is D. Cool. And those are your basic tools for probability. For combinatorics. Same thing as probability. It can scale up to things with a lot of twists and complexity, but you're always coming back to these same core tools. And you can use it for probability too. If you're thinking like how many total options, how many do I want? You can think about choosing groups out of those. All right. I could spend a lot more time on this, but it is late, at least where I am. I know folks are in different time classes, so I'm going to end there for now. If you are looking for more free resources, one thing you can do is come to the first session of any of our courses online for free. That's going to cover foundational quant and reading strategy. It's going to cover a lot of foundational stuff about the test too. So that's a good thing to check out. We also put these free prep hours on our YouTube channel, so you can go back and look at old ones on different topics. There's a ton of stuff on there. We also do a word of the day for vocab. So there's a bunch of good free resources out there for preparing. I wish you all lots of luck. Thank you, Marlena. Thank you all for being here. Sorry there was a little rough start with the tech stuff, but this was fun and kind of a lovely distraction for me. So I appreciate all of you coming, and good luck with your studies. Have a lovely night.